Awesome. The recording has started. So yeah, thank you again, Alex, for joining us. We are super excited about all the new products you guys are introducing into here. What is the changes that's coming, and what to expect, especially from the installer side. So I am gonna let you dive right in and start the session.
Perfect.
Thank you.
Okay, good morning, everyone. Let me know if you can see the screen. Is it coming up already?
Yes, we can see it.
Yeah. Doesn't even really show on my side here if it's sharing, but you can see, the first page, yes. Solar MD, like the black screen, right?
Yes, yes. And your red dot.
Perfect. Good. All right. Then, yeah, let's dive in right away, I guess. It's going to be short and sweet. We just speaking about the changes today of our new batteries, the cell changes we having currently right now. The last couple of batteries are supplied at the moment, and then definitely from kind of 1st of July we'll have the whole portfolio in a new offering with our new batteries, or the new cells in the same battery, yeah, that's the main topic for today, just to show you what the changes are, what are the implications to that. And if you have any questions, please let me know. Please ask questions as much as possible. If you have concerns, question why and what and how, so that we can answer them. I hope with the slides I can answer most of them, but I'm pretty sure you'll have some questions. So please feel free to, we're not so many. I don't even mind if you would probably open the mic and ask a question, raise a hand in it and ask a question, no problem at any given time. I think that should be very, very easy. All right, cool. Let's dive in. Perfect. All right. Okay. So right away, first page is the facts of the new cell we are using, and these are some of the main facts which are changing. So we can see this is the cell we used before, CB2W0. Now we're using CBC00. What we can see are only highlighted here the actual changes. Operating voltage is the same. The dimensions are also more or less the same, so it fits exactly into the same housing like our current battery. So from the dimension side, there's no changes at all. The changes are the capacity. So before we used a 280 amp hour cell, now it's a 314 amp hour. It just gives us that 10% more capacity in the total battery then. The max charge and discharge rate power is what was 1 C before, even though we limited it at 0.7 C in our battery, but the cell was a 1 C cell, and now it is a 0.5 C cell. So that's kind of like the main change, as well as the cycle performance was 6,000 cycles, and now we're having 7,000 cycles. So which gives us an additional lifetime or designed lifetime of the battery. If we look at now, if any questions to the cell itself, I mean, it was CATL before, and we're still staying with CATL. We're still using the biggest manufacturer worldwide, still 70% market share worldwide for cells. So still top brand, top quality brand. We still staying with CATL. We had a look at a few other ones, but we generally think CATL is the best quality product, and this is the only one which we want to use in our batteries as well. Okay, so the changes, the first ones are already announced last week or the week before, was already announced our residential product, the 14.3 SS4143. Our 14.3 like flagship residential product, is going to change to SS4160, where then obviously you can see 14.3. The back always says the capacity 14.3, and then it's then now 16 kilowatt hours. Also changed, this was announced this week, is our SS214, which is our commercial low voltage battery, which is changing to the SS216. Also then obviously 16 kilowatt hours. And on the high voltage side, what will change is also our SS6143 will become the SS6160. And this then goes, so the high voltage battery module, SS6160 then, will then also change in all our products, in the outdoor cabinet, in our outdoor storage battery, as well as in all our commercial and utility scale containerized solutions. It will change to the 16 kilowatt hour battery module. So the whole range will change. The only thing not changing is our 8.3 kilowatt hour battery. That battery actually is a battery which is where we use CATL cells, and that's because also the form factor is a different one. This one we couldn't just easily exchange to the new or similar cell we use for the 16 kilowatt hour cell, 16 kilowatt hour battery. So that will stay. What is changing? Let's start with some of the facts. So main fact is 16 kilowatt hour capacity in the same size. So it's the same look, just more inside, right? This is kind of like our messaging here at the moment. So same look, but more inside, which means we have now 16 kilowatt hour. Also as explained already, extended cycle life to 7,000 cycles, which then also in total obviously gives us a lower cost per kilowatt hour. The battery generally prices are a bit reduced, which comes from the 10% more capacity now in the battery, and as well as a little bit of a price reduction in the cell, gives us a definite, like in total, a lower cost per kilowatt hour. Additionally to that, because now instead of 6,000 cycles, we have 7,000 cycles, we also give a higher throughput guarantee. So there we have now 84 megawatt hours, which was before was 64 megawatt hours, 60 megawatt hours is now 84 megawatt hours. So it's a total of 24 megawatt hours more energy we guarantee that you can use through within the battery. So which gives generally also for any return of investment calculations or anything like that, it gives you more guaranteed energy out of a battery. So also a very important fact. So these are the main important facts what changed. And you will see it throughout all our social media activity. All these facts are highlighted and explained also a little bit more. If we now look at the kind of like fact sheet, this will be kind of like the information on the data sheets. And so what will change in detail? So rated capacity now is 16 kilowatt hours. Nominal power is now 8 kilowatt. If you remember before, it was 10 kilowatt. So we were actually able to charge and discharge a bit more energy from the battery. But that's the reason, because we used a 1C cell, where we now do using a 0.5 C cell. So 0.5 obviously means from the 16 kilowatt hours multiplied by 0.5, right, is 8 kilowatt. So the C, the capacity, so the charge and discharge rate compared to the capacity is 0.5, which means now it's 8 kilowatt. And then the current, charge and discharge current, is 175 amps, which was before 200 amps. So yeah, just please be aware of that, that there is a little bit of a reduction on the charge and discharge current in the battery, but that comes with the 0.5 C. But obviously, with having more capacity, lower price, this is kind of like a little bit of the only one reduction we have, where everything else is actually much better in the system or in the new battery. Same voltage, 51.2 volts, so nothing changes on that side. Energy throughput is 48 megawatt hours, and 7,000 cycles is the design cycle life. So this is the main facts which change on the data sheet. They're also now all available on our website. I'm not sure if you have seen our new website, which we just have launched. So yeah, new data sheets are also already available there. Now we had some kind of like, or we try to address a few questions which obviously come. One of the big one is what is with compatibility? So on the low voltage side, so we say upgrade with ease, which means it's compatible with all older modules. This is not just the SS4160, it's for all the models, right? So everything is compatible with previous modules. You theoretically, I mean, we have had it before that the people have used the 3.7, the 7.4, and the 14.3 in one system. And generally, it's all possible, especially on the low voltage side. You have no restrictions, all right? So you can use the new battery with the older modules, with the discontinued modules, and at no problem. This is very easy possible. The only thing we need to think about is as soon as we use high voltage systems, on the high voltage systems, because now we're working on a stack level, right? The whole stack. If we now, within one of the high voltage stacks, add another battery to it, and it's a 16 kilowatt hour battery, the new one, then we know that the whole stack, the charging and discharging current, will be reduced to 175, 157, 175. What's happening here this morning? 175 amps per stack, and so it will be reduced from 200. And that's just very important that we realize that, as well as the capacity of this one module will be reduced to 14.3 kilowatt hours from 16, because now we're having a whole stack where there's 10, 12 modules in series, and there we have the kind of like same like PV panels, like the weakest link more or less decides for the whole voltage as well as output power. So here we just need to be aware that it will be reduced, but the new battery is a little bit cheaper. So I think in general it's not a loss for the client to have then a new battery inside, which is 16 kilowatt hours, but only can provide 14.3. So it won't really affect his buying decision, because the new module is anyway a little bit cheaper. Let's look at another fact. More power, same space. So as said earlier already, so here there's also generally no restriction. All batteries are built into the same metal housing. So there is no restrictions. It's the same housing, same cabling, same racks. And this is for low voltage, high voltage, direct systems, or anything like that. It's the exact same housing. So there will be no change. You can exactly use what you already have, what you have maybe still in stock. So everything can still be used. Let's go to one more fact. More cycles, longer life. Also with this, we have more reliable performance, we have more return of investment, as well as more peace of mind. That's just because if we're having 1,000 more cycles within our guaranteed lifetime, and that gives us a longer lifetime, as well as more return of investment, because we can obviously use it more. We can charge and discharge more energy. So this gives us definitely a lifetime extension, as well as more guaranteed energy from the battery for a better price. So return of investment is definitely better. All right, then I'm coming actually already to my last slide of the changes. There's obviously also now on the cabinet, as well as the containerized solution. So now we can fit in up to 272 kilowatt hours in one outdoor storage battery. Same like with one, even if it's an indoor rack or anything like that, it will be now 272 kilowatt hours in total. And in a container, if it's just a battery container, we now reach up to 6.5 megawatt hours within one fully deployed high voltage containerized solution. So it gave us quite a bit more advantage on kilowatt hours be used in one system in the same space, as well as with reduced price, because it fits all into the same space with a reduced price. So this gives us quite a big new advantage, where we have a big price reduction in the whole system and can provide more power for our clients. Okay, that's more or less the main facts. Pretty quick. There's only 16 minutes now. Pretty quick and easy on the information. Does anyone have any questions on the change of the batteries?
Hi, Alex. It's Wessel, yeah?
Yes, Wessel, hi.
2 questions. Will your fuses stay the same size, 200 amps, or do we need different fuses now for this new range?
They will stay the same. The protection stays the same.
All right. And then the other one, on your previous data sheet, it showed the usable capacity on a 0.3 C rating, but the new data sheet doesn't show the usable capacity. So
yes,
what is the capacity of these new cells? Is it 90%, 100%, 70%?
So generally, it's 100% usable energy. I mean, we obviously recommend depth of discharge to 90% or like to 10%.
Yes.
So 90% of energy used within a system, it's definitely the safer way. But generally, it's 100% and 100% of the energy in there is usable. There's also with the new cells, they're actually even much more resistant against cold and heat, let's say. Their bandwidth of what they can actually work in is much bigger now. So, and we only discharging with a maximum of 0.5, which means that that was before with the 1C cell. If that 1C cell was discharged with 1C, it wasn't kind of like recommend that's, or that was the reduction of the kilowatt hours in the cell itself. But now with 0.5, that actually doesn't happen. So you can discharge and discharge the battery with 0.5 C, 100% at I think the temperature rate is like from 5 degrees to 50 degrees, and it has no really implication to the actual capacity of the battery. So it gives us a much bigger bandwidth of charging and discharging in the battery, because the currents are much lower. The heat emission is much lower.
Yes. Okay. Thank you.
Any other questions?
I have a question.
Yeah.
So just in terms of the discharge rate, it's a 0.5 C cell, but
yes.
Is it possible to briefly exceed that discharge rating of 157 amps, or
no?
It will shut down.
Yes.
Okay.
Yes. Yeah. That's not. We can't do that anymore. Before it was maybe a little bit possible because it was a 1C and it was reduced from our side to 0.7, but now it's 0.5 C cell, and we can't exceed that. Yeah.
Okay, and the BMS will stay the same. The functionality
yes.
in the BMS is exactly the same. So this I don't know if any other BMS does it, but I've only noticed it with the Solar MD BMS is this negative impedance, or it's like a faked voltage rise when the battery's discharging hard. The voltage that you actually measure versus what's reported by the BMS seems to be stays high. So I just want to know about that, because I noticed it in versions 191 and 193 of the BMS software. But I think the newer version seems to be slightly less aggressive. It's just
Yes.
from a Victron point of view, sometimes the voltage that are reported and stuff can cause issues with MPPTs running when the batteries are full, and a lot of PV, I've noticed.
Yeah, it's always been there. Like, obviously, there's a lot of or like a high current on the DC bus bar used directly. Then it lags sometimes a little bit until the battery is actually at that point. But with the 0.5C, it should generally even become less now, or should get much better.
Sorry, Alex, can I just add to that?
Yes.
So just to answer the question, so it's essentially a voltage compensation to create a linear voltage curve during charge and discharge, and the compensation was maybe a little higher than it should have been, and it has been corrected since version 200 plus on the BMS firmware. It is a lot less aggressive, but if you do still have cases where it's maybe overcompensating that voltage, then just let us know and we can take it up with the devs, but it's most certainly been rectified.
Okay, I have seen it on version 2. It still does it, but it definitely seems to be less aggressive.
Yes.
But yeah, we have one client who has one solar MD battery. He has quite a lot of PV, AC coupled and DC coupled, and it's a bit of a challenge. But I've installed another battery there just to kind of make the tank a bit bigger, and it seems to be behaving. But I'll have to see what happens in summertime.
Cool.
Yeah, I'll definitely bring it up with the support team if there's any issues. Then we need to look into it. Okay, any other questions to the new batteries?
Can I just ask, you did say they're compatible with the old 14.3s, obviously size-wise, but connecting them up into, taking a new 16 kilowatt hour and adding it to a 14.3 wall mount. Have you guys actually tested this? Because I've heard these compatibility things, but I just every time I sort of try and do these things, they end up not working. So I just want to know if you guys have done some extensive testing on that.
We have a lot of systems also in the market where all the previous versions are in one system, and they're all working, like the 3.7, 7.4, and 14.3, and it's all working.
So how does it work then so say I had a 14.3, which is generally allowed to have a discharge current of 200 amps. Now we add the 16 to the system. I guess the entire discharge would then get. How does the current sharing work, or how does the BMS decide? Is it 157 plus 200? Is the discharge?
350. Yeah, 357.
Okay.
I mean, it will generally share it to a certain point until the one battery can't really keep up with that energy, and the other one can generally then bring that power. But it will really happen, because if you extend the system now, where you have 14.3 batteries, they're already kind of like current-wise delivering enough to supply whatever is there. So now if you extend, you're just extending capacity, and then it will generally be shared. Everyone will get the same current. So that's normally the case of the extension, unless the system is completely extended. That also inverter power is extended as well. But in a very rare cases, actually, it's more capacity increase than actually power increase to the system.
Yeah, I think in cases where the inverter capacity is also extended with the battery capacity, then you'll need to, it clusters all the current values together. So it doesn't determine that the 200 amp now needs to be reduced to 157. So that needs to be considered then on the inverter side as well to limit the inverter max charge and discharge.
Yeah, so that's what I mean. So for example, if you have like a three-phase system, or you have a 30 kilowatt inverter setup, and now you put in an extra battery, what is going to be the limit there? I mean, the electrons don't know where they're coming from. They just come from the battery, but the one battery can only deliver 157 amps and the other one can deliver 200. So I'm just wondering how that gets managed.
Yeah, so in that case, if the system was already sized with correct 1-to-1 ratio or even more, then adding the other battery, to Alex's point, wouldn't be an issue. But if it is now extending into a range where you need an additional 157 amps, your net result is 314 amps over the two batteries. So
yeah.
From the battery management side, it's going to give a limit of 357, but from the inverter side, you would need to then limit the amperage that you can take from the batteries to 314.
Right.
It is possible. It is possible on the BMS to reduce the actual current amount. So we could essentially reduce the 14.3s or the 8.3 or whatever the other battery is down to the same as the 16. But typically we would prefer not to manipulate the BMS's values and just have the inverter management do that.
Yeah, okay. And what is your recommendation when you do this? Do you add the new battery and make it kind of the master, or do you keep the old battery as the master?
The cluster master is always determined by the lowest serial number in the chain. So that's automatically determined.
Okay, so it would be effectively the older battery.
It would essentially be the oldest battery, yes.
Okay.
Yeah.
Yeah, well then it depends. It depends how old the battery is, where it maybe makes sense to also exchange the BMS right away at the same time, to have them all at the same BMS, but that just depends how old it is.
Yeah, okay. So, I mean, are they, look, I mean, I guess this is not really specific to the battery, but maybe it's just some opportunity to ask some questions with regards to the BMS. I had quite a few batteries sort of like have issues. The sort of what appeared to be the cells going out of balance. Turns out it wasn't. It was just a firmware issue that needed to be resolved, which seems like it's been resolved in 203 plus or whatever. It does take quite a long time sometimes for the cells to balance. Can you clarify what is the ability for the BMS to balance? Is it 1 amp per channel, or is it more?
Do you know that exactly, Kyle?
So it's 0.2 amp
0.2
hours.
amps.
Yeah, so it's essentially
That's
1
very
amp
low.
hour would be 5 hours of balancing.
Right. Okay.
Yeah. So the board has got it's got two 400 ohm resistors per cell.
Yeah. Yeah, it's just
470. 470. You can check on the board. I think it's a
quite a while
470.
for some batteries to balance, and I was just trying to wonder. I thought it was 1 amp, but if it's 0.2 amp, then that kind of makes sense.
Yeah. So the best way to bleed off the energy would be when the battery is full, because the energy density sits when the battery is sort of in the middle range, that 3.2 to 3.35 volts. So from a balancing perspective, to balance the battery faster would be best to have it as full as possible around that 3.4 volt range. And for extended periods, if you can keep it there, then it will speed up the balancing process.
Yeah.
So like a UPS system typically has a, if everything's working properly, a well-balanced pack. Batteries that are cycled down to 20% and have to charge through the whole day back up to full, and then are recycled through the evening. They only get about an hour or two every day to balance. So it is sometimes good to maybe have them full for a couple of days just to give them time to align.
Yeah, I've noticed that definitely. So that's okay. Yeah, the one other thing is it's kind of fine for Victron systems in terms of being able to force especially now, like in winter, where generally there's just not a lot of sun in Cape Town, and so the batteries are effectively staying like below the 55 volts, so they're never getting to charge up, and obviously you can't reset the state of charge to 100% effectively, and then you get this. It can be like 5% per day what it looks like in terms of state of charge estimation drift. So you obviously now with Victron implementing the lithium the lithium setup for keep the batteries, making sure that they will get to 100%. I was just wondering how it can be dealt with in the case of the Sunsynks and the Dayas and that kind of stuff. Is there a good? I mean, I don't know if you guys probably don't. This is not really a battery issue as such, but I'd have noticed it can be quite bad with the solar MDs. The state of charge estimation with the batteries do not get to their 55 volts for long enough to reset the state of charge.
Yeah, are you still experiencing that where you have a sort of state of charge drift? Even on the newer firmware versions.
So I've updated most of the batteries to the latest firmware, so I haven't had enough time to see that. And what I have started to do on the Victron system is operate in optimized with battery life. So you get the dynamic sort of shift in the state of charge by 5% per day to try and eventually then the battery gets to 100%. And generally over a week it's okay. But yeah, I'm just wondering about the Sunsynk stuff, because there doesn't seem to be a mechanism to force this thing to, unless you have manual intervention. So I just thought if someone had a clever idea of those.
Yeah. So I mean with state of charge being a man-made calculation, it's based on energy in, energy out. So it's literally Coulomb counting. The algorithm has been reworked with the new firmware versions, anything over 200, and it should be pretty good now. I don't think we should see a drift anymore with Sunsynk specifically. So how the algorithm works is when the battery doesn't need to get to 55 volts essentially to do the realignment. It's about the cells getting to 3.4 volts. So once the cells start spending a period of time that's predefined by the BMS in that 3.4 volt range, then the SoC will start to align. The longer it spends there, the more time it has to align. So if there are cases that the firmware is still below 200, then I would say let's start with that. If it is drifting for some or other reason, there might be something specific to that site that needs to be addressed with the support team.
Yeah, as I say, I'm slowly upgrading all the sites to 200 plus or whatever. So I haven't had enough time. And obviously, like the Victron sites now with this, and even with the older battery firmware, keep the batteries or have the batteries worked and optimized with battery life. So the minimum state of charge is dynamically adjusted every day if the batteries don't get to 100%. So eventually, that once it generally works out that it's about a week before the batteries will get to 55%, 55 volts or 100%, and then it's fine. It's just those cases where the batteries used to stay well below, sort of like anywhere, sort of, the 55 volts. Okay, you explained that it needs to be 3.4 volts of the cells, but yeah, the batteries would report sort of 30 or 40% state of charge, but actually they were at 50. The pack was at 50 volts.
Okay, I mean that's obviously quite far out. I think the quick fix would be if there was a SolarMD logger on there, the support team can adjust that for you. But if there isn't a SolarMD logger, in that case, the quicker fix would be to switch the system over to a lead acid based charging algorithm, discharge the battery until it's essentially flat, which would be around between 48 and 50 volts, and then charge it back up full.
Yeah. Okay.
Okay, awesome. I think I think you guys can always send us an email, contact your sales manager if there's any further questions. But I think we have reached the end of today's webinar. Alex, thank you so much for sharing information, more information about the new products. We really do appreciate it. So I see there is a hand up. Can we make it a quick last question?
Yeah, sorry, it's actually not a question. I just wanted to say thanks to Solar MD. I've interacted a lot with their support team, and generally, like it's like my favorite battery person to interact with. None of the batteries are perfect, but the support is very good, and the guys are very eager to help you at any time. So I just want to say thanks for that.
I'm happy to hear that. Thank you very much. Appreciate it.
Awesome. Always great to hear some good feedback. Thank you so much. And yes, I'm going to end the recording now, and thank you to everyone, and enjoy the rest of your day. Thank you again, Alex.
Perfect. Thanks, guys. All right.
Enjoy your day. Bye-bye.
Bye-bye.
Thanks, bye-bye.